6 of Module 1, Chapter 1. So we're going to use the quadratic formula and discriminant to find solutions to quadratic equations. So we have factoring, we have graphing to solve quadratic equations. Not all of them are factorable, so we use complete and square. But we can see that when a does not equal 1, we need to divide everything by a. Well, quadratic formula allows us to find all solutions to any quadratic equation with any a that we have, and then this discriminant is a piece of the quadratic formula that tells us basically how many solutions we have and kind of what type of solutions we have. So I'm just going to jump into these 5 examples. I'll be posting the notes to this so you can take the notes, but I'm not going to go over the key concepts or anything like that. I'm just going to do the examples. Okay, so example number 1, I want to find real roots when c is positive. So here I'm given this pumpkin chunkin catapult that goes off, and it's calculated in feet per second. So that means I'm using this formula that we talked about kind of before with height of projectile. And basically I want to know when my height is 0. All right, so that means I put in 0 for h, and I basically want to solve this using the quadratic formula. So that's part 1, and then I want to interpret those based on its context. So here's the quadratic formula. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. You can look up this quadratic formula. You can look up a video of it, of kind of how to memorize it, and you can do it with song. But there it is, negative b plus or minus the square root of b squared minus 4ac. The whole thing is over 2a. Or you could write 2 equations, and I'll show you how to do that at the end. Okay, so b, my a is negative 16, my b is 124.4, and my c is 42. Okay, so I do negative b, so that'd be negative 124.4 plus or minus the square root of b squared. And remember, whenever you square b, put it in parentheses, because even when you square a negative, it's going to be positive here. And this is subtracting 4 times my a. I'd recommend always putting these inside the parenthesis. My a is negative 16, so make sure you have your negatives correctly, and my c is positive. All right, so then when I do this, the whole thing is over 2a. Okay, and a is, again, negative 16. Okay, so really this is 2 equations because I have a plus and a minus there. So it's really 2, but we'll go ahead and take these parts down. So I'm going to square my b there. That is 15,475, and then minus 4 times a negative, that's going to be a positive. So 4 times 16 times 42, that is 2,688. Okay, so that's underneath the square root, and then we can add those together. Bring all this other stuff down. 2 times a is negative 32. All right, so I'm going to bring that down. That is a 4. And then I'm going to add these 2 together, so I get 18,163.36. And then again, all over negative 32. Okay, and so really this is actually 2 equations. And so it's actually negative 124.4 plus the square root of 18,163.36 over negative 32. And then it is also negative 124.4 minus the square root of 18,163.36 all over negative 32. And now you can type this into your calculator. Negative 124, hit the negative button. 124 plus the square root of 18,000, but sometimes you might have to either hit alpha link to do a fraction, alpha link to create this fraction, or you can put this in parentheses and then hit divide by negative 32. And you might have to do parentheses on the bottom as well for that negative 32. And then you come back, highlight it, just scroll up, change that positive to a subtraction, and then you can go ahead and hit enter, and then you should get your 2 answers of 8.1 and negative 0.32. So what does this mean in context? So what does this 0.81 mean and 0.32 means? Well, if we read our question, it seems like that would be when this pumpkin lands at 8.1 seconds, but then going backwards, we can see that it would also land backwards at negative 0.32 seconds. So that's kind of irrelevant. I don't need that one because I start higher, right? I start at 42. And so that's really the difference here is this is how many 8.1 seconds for it to land. And that's when, or hits the ground, right? For the pumpkin to hit the ground. So that's our results. Negative 0.32 was irrelevant because that would be going backwards because I start at a height of 42. So why are the roots not 0 and 0.81? Think about that, right? Why is it not 0 and 8.1? Kind of already give you the answer because it starts at 42 feet, right? Off the ground. And what assumptions did you make about the height at which the pumpkin hits the ground compared to when it starts? Again, we started at 42 feet and then we landed at 0, right? So that is kind of the assumptions that we make when we start at 42 feet and we hit the ground at 0. So that's example number 1, and I'll make a video on example number 2, 3, 4, and 5. So there'll be 5 separate videos.